But how the matter can exist in different states of different states? So what could be the reason if you want to know? What keep the matter in different states? We will discuss in detail about the intermolecular forces, and also we'll talk about thermal energy of particles. Most of the observable characteristics of chemical systems, chemical system means, so whatever the substance you take, the most of the observable characteristics of chemical system of any substance if you take, which are familiar, represent or their properties depends upon its bulk status. If you want to discuss about the properties of matter, then you must talk about that collection of molecules or collection of particles. You never discuss with a single molecule, right? For example, here there is one water droplet is given. If I give one droplet of water, can you wash the cloth? Is it possible? If I give one water molecule, can you wash that cloth? Can you even wet the cloth? Is that wetting is possible with one water molecule? Is wetting is possible with one droplet of water molecule? Never, not possible. But collection of water molecules, collection of water droplets will make bulk of water. Then wetting is possible. Then washing is possible. Then water can perform the work. Then water can attain the state with a large number of molecules, with a collection of molecules. So here I would like to stress on this before going to talk about the states of matter. So let's talk about how we describe the characteristics of a substance, how we describe the properties of the matter based on the large number of atoms, based on the large number of molecules, not on the single molecule. You cannot boil one molecule, you cannot wet with one droplet of water, but we can boil large amount of water. Take water into the container and boiling is possible in this. Boiling is possible with large number of water molecules, large number of water droplets. Then large number of these water molecules attain energy and they can perform the work collectively. Collective task is done by large number of molecules, but single molecule cannot perform the work. All the molecules will boil, all the molecules gain an equal amount of energy, then all the molecules perform the work. That is boiling of the water, we say. That means collection of water molecules have wetting properties. Individual molecules do not wet. The water can exist as ice, water exists as a solid, liquid, gaseous state. That means water, vapor and steam. Here I would like to talk about collection of water molecules. The more number of water molecules you take, among them there is other kind of forces exist which decide the state of the matter. If you take large number of molecules, among them there is continuous interaction. Molecules interact each other. As the molecule interact each other between them, among them, there is a force of attraction develops. That depends upon the distance between the molecules. Two kinds of force we'll talk about. One is intermolecular force. These intermolecular forces are the molecular interactions, maybe two types. One is repulsive, other one is attractive forces, we say. And these are the forces that determine the state of the molecules, motion of the molecules or particles, we say. And as a result of that motion of the particles, the molecules gain the kinetic energy, and with that kinetic energy generate the thermal energy. So the balance between these intermolecular forces and the thermal energy of the molecules will determine a state of a substance. If you want to know the state of the substance, then we must know about the intermolecular forces. What are intermolecular forces? Just now I mentioned intermolecular forces are two types, attractive and repulsive forces. These attractive and repulsive forces happen between the particles. What particles could be the substance, atoms and molecules, we say. The attractive intermolecular forces are known as Vander Wal forces. Attractive intermolecular forces are said to be Vander Wal forces, we say. I'm talking about intermolecular forces. The attractive forces are called intermolecular forces, and these attractive intermolecular forces are known as Vander Wal forces. And first time that Vander Wal scientist proposed this, hence Vander Wal forces, we say. These Vander Wal forces considerably in a magnitude and include how many types based on the magnitude of these Vander Wal forces. So we say three types of, one is dispersion forces, second one is dipole forces, third one is dipole induced forces, we say. So dispersion forces and London forces, dipole forces, dipole induced forces are the types of Vander Wal forces. Let us discuss about dispersion forces. So what are the dispersion forces? These dispersion forces, otherwise called London forces, also we say. Now, what are the dispersion forces? Actually, the dispersion forces, London forces, exist among the atoms or the molecules having non-polar nature. So that means the dispersion forces, London forces, takes place where in non-polar molecules or atoms having non-polarity and atoms having electrical symmetrical property, atoms and molecules having no dipole moment property. That means the electronic cloud is distributed, symmetrically distributed in that molecules. Such molecules develop dispersion forces. So how the molecules develop dispersion forces? Let us look into this example we'll discuss now. A typical example, atom having, so A atom and B atoms, both are symmetrical. So in both atoms, the electronic cloud is distributed in symmetrical manner, having that, so non-polarity, non-polarity molecules. So non-polarity molecules mean the electron charge or electron cloud distributed in the atom symmetrically, then non-polarity we say. And such molecules, mostly this dispersion forces we could see in noble gases like helium, neon, noble gases, because most of the noble gases produce this dispersion forces and London forces since they are non-polar, and or the molecule like diatomic molecule, chlorine, hydrogen. So these also produces dispersion forces and London forces we say. But how these dispersion forces are created in non-polar molecule? Sometimes when we bring these molecules very closer, when the molecules come close at particular critical distance, the molecule come closer. When the molecules are brought together, these non-polar molecules are brought together at the critical distance. So one of the molecule loses its symmetrical charge. The symmetrical charge is spontaneously distorted. The symmetrical charge is spontaneously develops the dipole. That means the symmetrical molecule or atom distort. As it gets distortion, there is a polarization takes place. In instantaneous dipole is formed. One side positive charge, other side negative charge is produced. Partial positive, partial negative. So if a atom gets a distortion or polarized instantaneously, means symmetry is distorted. It may be by mechanical pressure, or it may be by due to the movement. And immediately what happens? So this is the polarized or instantaneous dipole disturb other non-polar molecule. When non-polar molecule gets disturbed, then this instantaneous dipole shifting to across all the molecules, and other molecules also polarized. This means here A atom, its instantaneous dipole disturb other B atom, and B atom can induce the dipole moment in other non-polar molecules. When A atom distorting other B atom, the A atom negative charge attracting the positive charge of that B, the negative charge of the B will attract that positive of that A. Automatically that non-polar molecule come closer. When molecules come closer, the Vander Wal force increases, dispersion forces increases. When dispersion forces and the London forces increases among them, the state of the matter changes. It might be liquid or it might be solid. So particularly liquid, the state of the matter will change because of the dispersion forces. The dispersion forces are said to be weak Vander Wal forces, we say. Weak Vander Wal forces we say, not strong, because the charges produced among the molecule is discrete charges, partial charges, weak charges we say, not complete positive charge and complete negative charge. That means here between A and B there are temporary dipoles are formed. These temporary dipoles will induce other molecules also, and between them the attraction force will develop. That attraction forces first proposed by the scientist, physicist Fridge London. Hence these are said to be London forces also we say. London forces. London forces also we call this. And so these forces are attractive forces we say, or interaction energy we say. This is attractive forces inversely proportional to the sixth power of the distance between the interacting particles. This is 1 by r to the power 6, the distance between the two particles. These forces are important only at the short distance, 500 picometers. So their magnitude depends upon the polarizability of the particle. Polarizability of the particle. So these are London forces or dispersion forces we say, which are weak attractive forces among the molecules. Now the second type of intermolecular forces are